Hey guys, it's Miss Smith. Today we're going to be doing Unit 2.2 on constant rates of change. Alright, our central question today is how can you identify and represent proportional relationships? Okay, so we are going to be discovering proportional relationships. First question. A giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches or 10.5 inches. So 3 seconds to travel 10.5 inches. What operation do you use to solve this problem? Use a pictorial representation below. Okay, so what do y'all think we're doing on this question? This kind of reminds us of unit rate in a way, because we are wanting to find how long does it take 1 second, how far do we go? So if we draw a picture here, 10.5 inches, we want to know how much it is for 1 second. Or we can know how much it is, how many inches you go in 2 seconds. So how would we find unit rate? Very good. We are going to divide 10.5 divided by 3, because we want to know how many inches per second. So when we divide this, of course, top dog in the house, bring it up, we're dividing by 3. So 3 goes into 10 3 times. Very good. Minus 9, bring down the 5, so 3 goes into 15 5 times. Very good. So we have how much it is for unit rate, how much happens in 1 second. So let's go ahead and put 3.5 here. Alright, now we are going to go to how much happens in 2 seconds. Well, if we look back at this, if for every 1 second we go 3.5, what do you think happens, or each of these is going to be 3.5. So what do you think happens if we have 2 seconds? How many inches are we going to go? Very good. We would multiply 3.5 times 2, or add 3.5 plus 3.5. So in 2 seconds we go 7. Awesome. Alright, and then we know from our word problem that for every 3 seconds we went 10.5. So what do you notice from 3.5 to 7? Good. We're going up by 3.5 each time, just like our picture over there. So then what's 10.5 plus 3.5? Good. It would be, well, of course we got to do our decimals. Bringing it up, it would be 14, and so forth. Okay, so every time you are going to be adding 3.5 here. Now let's draw what we just did over here. This is a different way to do it. We are going to be dividing in order to get each one here. Let me cover up this next one. We're going to be dividing here. So what did we do on the first one? Okay, we needed to find unit rate. So 3.5 divided by 1, or inches per second. Of course, anything divided by itself is 3.5. Let's go to the next one. If I want to know how many inches per 2 or for 2 seconds, we would do 7 divided by 2, which would give me 3.5. Okay, the next one, like we did just right here, it would be 10.5 divided by 3, and we got 3.5. Okay, what if we had, on the next one, what if we had 14 divided by 4 seconds, we would get 3.5. So what do you notice about what happens when we start dividing second, or inches per second, or inches for every second? Very good. We notice that they are all equal. The decimal form of those are all equal. Okay, the next thing, how would you describe the rate of speed at which the tortoise travels? I would say it's the same. So constant means that we're at a constant rate of speed. So that means we are at the same speed. So 3.5 each time. Okay, so this is kind of, branching off of unit rate. So we start at unit rate here, and we're going up proportionally at a constant rate. Okay, vocabulary to remember. I'm going to read it out loud, so you just go ahead and fill it in. Okay, I had to kind of smush mine together, but when two ratios fractions or rates are equivalent. Okay? That is what a proportion is. So each of these fractions, 3.5 over 1 is equal to 7 over 2. 7 over 2 is equal to 10.5 over 3. So all these, all those fractions are proportional, or they are equivalent. Okay, rate of change. Rate of change is a rate that describes how one quantity changes in relation to another quantity. So what do you think our rate of change was in our first problem? Good. Our rate of change in our first problem was 3.5 or 3.5. That was our rate of change, what we're going up by. Okay, proportional relationship. Rate of change is constant, or in which the ratio of one quantity to the other is constant. So you have a relationship with your mother, right? Or a friend. Relationship means that we have, we're in relation with each other. So all these fractions or ratios have a proportional relationship to each other, because when you divide them, it all comes out to the same constant rate. Okay, so let's try another example, because I know from all that information it might not be clear just yet. And this is kind of a tough one, tough unit. But we're going to get through it. We're going to know it. Okay, Callie earns money by dog sitting. Based on the table, is the relationship between the amount Callie earns and the number of days a proportional relationship? Okay, look at proportional relationship. It means when we divide these numbers, are we going to get the same number or the same decimal form? So let's test it out. If we divide, we have to see if these are proportional fractions. So is 1/16 or 16 over 1 proportional or equivalent to 2 over 32 or 32 over 2? So the way we do this is we want to find out the amount earned. We want to find the amount earned for each day or for days. Okay? So we can put per here, because what does per mean? Good. It means unit rate. So we are finding out for one day, for each day, she earns $16. So how much does she earn if she works for 2 days, or 3 days, or 4 days, or 5 days? So we want to know the amount earned per day, and we can replace any number to find out how much she earns in that amount of days. So our rate, let's set up some proportions. So if I want to know the amount earned per day, if we start out with unit rate, remember from yesterday, per means divide. So amount goes on top, divided by 1. So amount per day. So for every day she works, she earns $16. Okay? Now if we put 32 over 2, what is 32 divided by 2? Good, 16. Okay, that should be mental. Now let's just make sure. If I worked 3 days, then I would earn $48. Let's just make sure it is a constant rate of 16. So 48 divided by 3, if we do it over here, it would be, yes, it is 16. So 16 is our constant rate of change. So rate is equivalent to 16 per day, which we called this a unit rate, correct, from yesterday, or we earn $16 each day we work. And it goes up consistently or constantly $16 a day. Alright, let's do some more examples. Okay, so I want you to pause me and I want you to try the back. I want you to do number where it says your turn. I want you to try that one by yourself and then come back. Okay, so this question, welcome back. I hope you paused me and tried it by yourself. For this question, I want to know the distance for each or every hour, because time here is represented in H, so I'm assuming it's hours. So distance per or for each hour. Okay, so in this problem, it's asking, the table shows the distance Katie drove on one day of her vacation. Is the relationship between the distance and time a proportional relationship? Did she drive at a constant speed? So we know constant and proportional relationship go together? So let's find out. Okay, so if I want to know the distance for each hour or distance per, which means divide, I'm going to put it in the exact order. So distance would be 65 divided by 1. Of course, anything divided by itself is 65. Okay, let's see if we get 65 for if we drive for 2 hours. So 120 over 2, would you get 65? No, I would get 60. So is this consistent? No, it's not. So I can already tell this is not equal rates. This is not an equal rate. My unit rate was 65, but my next rate for 2 hours was 60. So this is not equal because her speed changed. So this is a I'm going to abbreviate for time's sake. This is a non-proportional relationship. Okay? Alright, let's go to the next one. Alright, this is where, it shouldn't be hard, but this is where we need to write equations. An equation, as you can see, means where we're going to have an equal sign. Alright, so equal and equation kind of, that can help you remember that. Okay, let's fill in the blanks here. I'm going to go ahead and put a new paper so I don't lag and you can copy as we go. Okay, so writing an equation for a proportional relationship. I'm going to read it out to you so you can keep up without it lagging. Okay, constant of proportionality. This is a very, very important vocab word. Constant of proportionality. If there exists a proportional relationship between x and y, that means that we have a constant rate of speed, which when we divide our fractions from our table, we get the same number. You can describe the relationship using the equation y equals kx. So what does k and x next to each other mean? Very good, multiplication. So we are saying y equals k times x. So the constant of proportionality, or the constant rate of change, is represented by the variable x. So when you divide those fractions, or when you divide those ratios to find that constant number, okay, that's called a constant of proportionality. So that's exactly what up here would be if we got the same number, which we didn't, so this is non-proportional, but if we did, this would be a proportional relationship. If it was 60 and 60, that would be your constant, or constant of proportionality. Okay, we will go over this next thing another day, but another way you can write the equation is k equals y over y divided by x. But we'll go over that another day, so don't worry about that right now. Okay, so I'm going to switch back to my blank paper so we can go over that, the next part. Okay, so example, 2 pounds, here we go, 2 pounds of cashews shown cost $19, and 8 pounds cost $76. Show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. Okay, but Miss Smith, we don't have unit rate. Okay, that's okay, because what I can do is I can find the constant of proportionality, or the constant rate of change, when I divide these two numbers. And then I can find my unit rate. Alright, so if I divide 19 divided by 2, for time's sake, I'm going to go ahead and give you that answer because I'm going to assume we know how to divide by now. So that would be 9.5 when I divide this two, or 1 over 2. So whatever you got on that, whichever way is fine. So then I'm going to not use decimals for right now. Let's go ahead and use another rate, not the unit rate, but another rate. And let's say number of pounds for $8, I would get 9.5 when I divided. So what is our constant rate of change when we divide? Good, it's going to be 9.5. So the first thing we got to do is identify what our variables represent, because do you know what k and y and x anything represents right now? No, you don't. So we're going to have to identify those variables first. So x here, I know your table's kind of blurry, but x would represent the number of pounds of cashews, y is the cost in dollars, and then k is the constant of proportionality, as the constant rate of change, and the number that would represent k would be 9.5, because we divided and got that as our constant rate from one fraction to another. So the equation for the relationship would be as simple as this: y equals 9.5 times x. Now, Ms. Smith, how did you get that? Remember, our equation can be represented as y equals k times x. We just replace the k and that's it. So our constant rate, or our constant of proportionality, is 9.5, so you just replace with k, because that's what k represents for this problem. Okay, let's try one by ourselves and then we're done. Okay, for I'm trying to get this focused. For a school field trip, there must be 1 adult to accompany 12 students, 3 adults to accompany 36 students, and 5 adults to accompany 60 students. Is the relationship between the number of adults and the number of students a proportional relationship? Okay, when I read that, I really can't do anything without having a table. So if you had this without a table, you would need to make your own table. But luckily, they gave us a table right here. So in this case, we want to know the number of students for every 1 adult. So we have our unit right here, because we have it over 1, or 1 is a part of our ratio. So here, I'm going to make sure my unit rate is consistent with the other 2 rates. So 12 divided by 1 is 12. Let's just make sure this is constant. So 36 divided by 3, is that 12? Yes, it is. And let's just make sure on this last one, 60 divided by 5, is that 12? Yes, it is. Okay, because these we all should, memorize and know. So we do have a constant rate of change, which is what? 12. Very good. And we also have, or which is also called, the constant of proportionality. So going to the next one. This should seem pretty easy now. I mean, it's this easy, so don't overthink it. It's really this easy. Okay, so what would if you're confused on how to find a y and an x, well, let's think about it. If I plug in k and I put 12 here, if you're confused about which one is which, well, 12 times, let's replace one of these numbers. So would it be 12 times 12 would be 144? Do we see that anywhere? No. So we know that we have to do 12 times 1 if we're going to be using unit rate, and we get the number 12. Correct? And then if we did 12 times 2, it would equal, 2. 12 times 3 would equal 36. So notice how I'm replacing, where is 1 and 3 here? Good, it's with adults. So we know adults would represent the x, because I replaced it here with 1 and 3 to equal these numbers. So x would represent the number of adults, and y would obviously represent the number of students. So see how you can kind of, do it in your head and figure it out by replacing x with, either this or this to see what you would get for y. So our formula would be, or our equation would be, y equals something times x. Well, our constant number we kept plugging in, or our constant of proportionality would be 12. So of course that is going to represent k, which we can put down there. Okay, this is a lot of information. We're going to, flip video is just a preview. So I hope that you got a little bit of a preview, but we're definitely going to go over this in class and make it clear. So if you aren't understanding, it's not the end of the world. We'll go over it in class. This is just a little preview of what we're going to be going over. Okay, y'all have a great night.